Answering particulate nature of matter questions with detailed explanation. Question number 1 says, which of the following ions have the same number of electrons as neon? Look at the elements we're given. Fluorine, which has an atomic number of 9. Neon itself, which has an atomic number of 10. Sodium, which has an atomic number of 11. Magnesium, which has an atomic number of 12. And aluminium, which has an atomic number of 13. Roman numeral 1 says sodium plus. Roman numeral 2 say magnesium 2 plus. Roman numeral 3, aluminium 3 plus. And Roman numeral 4, fluorine minus. Now, this is what it means. This is which of the following ions, that means these ions have the same number of electrons as neon. Now, neon is a neutral atom here. Now, for neutral atoms, there's something you should know. For neutral atoms, let me push this forward. For neutral atoms, the number of electrons, this is question number 1, number of electrons is equal to the number of protons, which is equal to the atomic number. This is what you should know. This is the key knowledge you should know from question number 1. The number of electrons is equal to the number of protons is equal to what? The atomic number. That means for a neutral atom, this is for a neutral atom. Don't forget, this is for a neutral atom. Now, neon is a neutral atom and it has 10. The atomic number is 10. So if the atomic number is 10, the number of protons is 10 and the number of electrons is also 10. But for ions, you can lose the number of electrons. For sodium here, sodium has an atomic number of what now? 10. You can see from the question we saw that sodium has an atomic number of 10. Now, since it has an atomic number of 10, but we saw sodium plus. Now, sodium plus means it has lost 1 electron. And since it has lost 1 electron, it therefore means we have 10 minus 1. So when you lose an electron, it is plus in chemistry. So 10 minus 1 is equal to what? 9. Don't forget, for neon, we have 10 electrons. For neon has 10 electrons. Now, sodium is 10. Magnesium 2 plus is going to be what now? Magnesium has an atomic number of 12. So 12 minus 2. So the number of electrons, let me write this here. Number of electrons is going to be what? 10 electrons. Good. We go for aluminium 3 plus. Now, aluminium 3 plus, aluminium has an atomic number of 13. So we have 13 minus 3. So it lost 3 electrons. So it's going to be what now? 10 electrons. Again. And lastly, we have fluorine. Now, fluorine minus. Minus means it has what? Gained an electron. So we have fluorine minus. But what is the atomic number of fluorine? 9. So we have 9 plus 1, which is equal to what now? 10 electrons. From this, you can see magnesium 2 plus, aluminium 3 plus, and fluorine minus all have the same number of electrons as a neutral atom of neon. As a neutral atom of what? Neon, which also has 10 electrons. So our answer is going to be 2, 3, and 4 only. So 2, 3, and 4. That's option B. And option B is our answer. Now, for question number 2, it says, which of the following compounds have the same molar mass? Now, look at the compounds. We're giving the relative atomic masses of the elements we'll see in the compound. So we have I, which is CaCO3. We have KHCO3. We have this and we have this. Now, to find them, we would have to find the molar masses of each of these compounds. So let's start. For question number 2, now for question number 2, so let's start with CaCO3. Now CaCO3, to find its molar mass, we would have to start by finding what is the relative atomic mass of calcium. Now we're giving it to be what? 40. Now since it is 40, how many atoms of calcium do we have here? 1. So we have 1 times 40 plus relative atomic masses is, or the molar masses of the compound is just going to be the sum, their relative atomic mass in grams per mole. Now, since we have for calcium to be 40, for carbon, the relative atomic mass is what? 12. You can see it here, 12. Now we go, how many atoms of carbon do we have here? 1. So we have 1 times 12. Plus oxygen is what? 3. We have 3 atoms. Times, if you check, the relative atomic mass to be 16. So 16. Now, if you add all of these, we would have 40 plus 12 plus 48. Summing all of these together, we would have 100. So this is going to be 100 grams per mole. Don't forget, they said molar mass. If they had said the relative atomic mass, then we would have 100, but no unit. So 100 grams per mole. Now let's find for KHCO3. So we have KHCO3. Now, potassium has a relative atomic mass of 39. And how many atoms do we have here? 1 times 39. Plus hydrogen has a relative atomic mass of 1. So we would have 1. How many atoms? 1 times relative atomic mass 1. Plus carbon has 1 here, 1 atom. And don't forget we did 12 here, so 12. And oxygen is going to be what now? 3 times 16. Now you would have here as 39 plus 1. 1 times 1, 1. Plus 12, 1 times 12 is 12, plus, sorry, I didn't put a plus sign here, plus 3 times 16, which is what? 48. Summing all of this together, we have 100 gram per mole also. So we can see we have already started doing it. This is for I, this is for II. So we are going for III. So for III, we have NH42SO4. So we have, let me write this here, NH4 2SO4. Now this is also written as, now because this 2 is for all the atoms that are in the bracket. So it is basically me writing N2, 2 times 4 is what? 8. So we have 8SO4. This is basically what you are trying to say here. So let us now find the molar mass of this. I mean, it's written this, I wrote it this way for us to understand it better. So let's do it this way. Now, nitrogen has, we have 2 atoms of nitrogen here. So we have 2 times, what is the relative atomic mass of nitrogen, which is 14. You can see there 14. So we have 14 plus, now what is the, how many atoms of hydrogen? 8 times, with the relative atomic mass of hydrogen, we looked at it, 1, plus for sulfur we have 1 atom times, what is the relative atomic mass? Is 32. So 1 times 32 plus oxygen is going to be what now? 4 times 16. Now, if you just do this and sum all of them together, you would have an answer of 132 grams per mole. Now this is for III. And lastly, we have IV, which is copper 2 tetraoxosulfate 6, which is IV copper 2 CuSO4. Now for this, copper has how many atoms here? 1 times, what is the relative atomic mass? 63. So we have 63 plus sulfur is how many atoms here? 1 times, what is the relative atomic mass? We looked at it, 32 plus oxygen, which is what? 4 atoms times 16. So we already have a hang of it now. You sum all of these together, we would have 161 grams per mole. Now, the question says, which of the following compounds have the same molar mass? So, which of them have the same molar mass? I and II alone. They are the only ones. So, our answer is what? Option A. Question 3 says, which element contains the greatest number of moles? Which elements contain the greatest number of moles? We have A, 8 grams of helium. B, 48 grams of carbon, C, 78 grams of potassium, and D, 130 grams of zinc. So which element contains the greatest number of moles? Now, there are two formulas you need to be fully aware of. First one is that number of moles, N, is equal to your mass in gram all over your molar mass, or you can say your relative molecular mass. So I'll write it relative molecular mass or your molar mass. But if you use your mass in gram, you should be using your molar mass. You should be using your molar mass because your relative molecular mass doesn't have a unit. So I would say molar mass instead. Say molar mass instead. Okay? You also have your number of moles also has another formula, which is your number of atoms or particles or molecules divided by 6.02 times 10 raised to the power of 23. It also has another formula, which is number of moles is equal to concentration times volume. We're given the masses in grams, and that's what we are going to be working with. We are going to be working with the formula mass in grams all over the molar mass. Now let's start. 8 grams of helium. Now this is question number 3. Let me put it here, question number 3. Now 8 grams of helium. We're given 8 grams of helium. So for option A, 8 grams of helium. So the number of moles will be equal to 8 divided by 8 grams divided by, what is the molar mass of helium? The molar mass of helium is 4. So 4 grams per mole, don't forget. So 8 divided by 4 would give me 2 moles. So that would be my answer, 2 moles. For helium, it is 2 moles. We go to option B. Option B says 48 grams of carbon. So the number of moles is equal to 48 grams divided by, what is the molar mass of carbon? It is what? 12 grams per mole. We looked at it here. They gave us relative atomic mass of carbon the other time as 12, but for molar mass, don't forget to write per mole. So it will be 48 divided by 12. That's 4 moles. 4 moles. C, we have, what were we given in C? 78 grams of potassium. 78 grams of potassium. 78, yes, 78 grams of potassium. So N will be equal to 78 grams divided by the molar mass of potassium is 39 grams per mole. What am I doing? 39 grams per mole. And when you divide 78 divide 39, you get 2. So 2 moles. And D, we're given what? 130 grams of zinc. So N is equal to 130 grams divided by the molar mass of zinc is 65. So 65 grams per mole to be equal to 130 divided by 65 is 2. So we have 2 moles. As you can see, 2 moles, 2 moles, 2 moles, 4 moles. 4 moles is greater. So option B is our answer. That means which element contains the greatest number of moles? It is 48 grams of carbon. The last question says, a particle that contains 17 protons, 18 neutrons, and 18 electrons is A, a negative ion, B, a positive ion, C, an atom of a metal, D, an atom of a non-metal. Let us analyze the situation here. Now they say the particle contains 17 protons, 18 neutrons, and 18 electrons. What are we meant to understand from this question? So question number 4, there's something you should know about question number 4 is, it is trying to test your knowledge on the fact that what I first discussed about was for a neutral atom, don't forget, for a neutral atom, the number of protons is equal to the atomic number, which is equal to the number of electrons. Yes. So always keep this in mind for a neutral atom. That means the number of protons should be equal to the number of electrons for a neutral atom. You see, for an atom, let me use, for example, sodium. And I say sodium has an atomic number of 11. The atomic number is always equal to the number of protons. If you change the number of protons, you have automatically changed that element. So let's assume I change this number to 12. It automatically means I have a different atom, which is magnesium. Yes. So the number of protons is always equal to the atomic number. But for a neutral atom, the number of protons is equal to atomic number, which is also equal to the number of electrons. So if the number of electrons is totally different from the number of protons, it therefore means that something has changed. That is, we have an ion. We no longer have a neutral atom. Good. So if, for example, sodium having number of protons is supposed to be 11, which is equal to the atomic number 11, and I say sodium has the number of electrons 10, it means sodium has lost 1 electron because it is supposed to be the same with this. So coming back to this, we have 17 protons, which means the atomic number is 17, but the number of electrons is what? 18. So we have 18 electrons. So you see the number of protons is not equal to the number of electrons. It therefore means it has gained 1 electron. And gaining of electron means, you saw when we did fluorine, we saw negative. It means you to be what? This is what we call an ion. So it will become a negatively charged ion. So if you want to remember an ion, a negative ion. So it becomes a negative ion. So from this, you can see that this atom, whatever a particle we have here, has gained an electron. Because normally the number of protons is supposed to be equal to the number of electrons for a neutral atom. But since it has gained electron, it therefore means it is a negative ion. As you can see, a negative ion. And that is option A. Thank you very much, and I'll see you in the next video.